Okay, this video accompanies the 1.5 conditional statement student companion example, TryIts. So let's look at example 1. Okay, so they want us to write each one of these as a conditional statement. So a triangle with all angles congruent is equilateral. So we could say something like, if a triangle has all angles congruent, or all congruent angles, then it is equilateral. Could have been, if a triangle is equilateral, then it has all congruent angles, would also be a conditional statement. Okay, let's look at number B on here. Alberto can go to the movies if he washes the car. So this is kind of our P part already. So if Alberto washes the car, then he can go to the movies. It also could have been, if Alberto goes to the movies, then he washes the car. Either one of those would be a conditional statement based on those. Let's look at the example 2. Try it. Want to find the truth value of each conditional. Now, remember the truth table. You got P, Q, value. If they're both true, the value is true. If the hypothesis is true but the conclusion is false, the statement is false. If the hypothesis is false and the conclusion is true, it's a true statement. And if the hypothesis is false and the conclusion is false, we say it's a true statement. So there's our truth table for these. So let's see. So if a quadrilateral has a right angle, so I single underline the hypothesis part and I double underline the conclusion part. So we're talking about a quadrilateral with a right angle, so assume that's true. Then does it have to be a rectangle? So we're looking for a counterexample. So let's see, a quadrilateral has 4 sides. So let me make a right angle. And I'll make one side really long. There's 2 sides. Let's do another side out this way. And 4 sides. So here's a quadrilateral that has one right angle. But it's obvious it's not a rectangle. That makes this a counterexample. And that means that the conclusion is false, since I could find a counterexample, which means the statement is false. Let's look at B. If X is the midpoint of AB, then X lies on AB. So if we kind of draw a segment AB here, and we put X as the midpoint, we'll mark it so it's the midpoint. And it says then X lies on AB. Well, definition of midpoint, the midpoint is a point that's halfway between A and B on the segment. So that's going to be a true statement. So if X is the midpoint, there's the hypothesis. Then it lies on AB. That's the conclusion. The hypothesis is true and the conclusion is true. This is a true statement. So look at example 3. Write and evaluate the truth value of a converse. So if a polygon is a quadrilateral, then it has 4 sides. The hypothesis is polygon is a quadrilateral. The conclusion is then it has 4 sides. We want to write the converse which is Q implies P. And so we would write if a polygon has 4 sides, then it is a quadrilateral. So let's look at it. We want to evaluate the truth value of it. So let's assume that we have a polygon with 4 sides. And this is really a definition. A polygon that has 4 sides we call a four-sided quadrilateral, 4 sides. So this is really true on both sides. It's a true statement. Let's look at the next one. If 2 angles are complementary, now 2 angles are complementary means add to 90 degrees. Then their angle measures add to 90 degrees. So this is actually another definition. So we want to form the if part, the hypothesis is there. Up here, this is the hypothesis, this is conclusion. This is the conclusion. To form the converse, we want to swap the Q and the P's. So if 2 angles measures measures add to 90, then they are complementary. And this is actually our definition that we're going to use for complementary. Complementary, 2 angles whose measures add to 90. Supplementary, 2 angles whose measures add to 180. So this is also a true statement. Let's move on. Example 4, write and evaluate the truth value of an inverse and a contrapositive. So write the converse, the inverse, and the contrapositive. What's the truth value of each? So if today is a weekend day, that's the hypothesis. Then tomorrow is Monday, that's the conclusion. We want to write the converse. The converse is Q. The inverse is not P, then not Q. And the contrapositive is not Q, then not P. So we want to write each one of those forms and then evaluate them. So Q implies P. This is the converse. This next one's an inverse and contrapositive. Okay, so let's change colors up. So the converse would be if tomorrow is Monday, then today is a weekend day. And this seems to be a true statement. Assume that tomorrow is Monday, that means today must be Sunday, and Sunday is part of the weekend. So this is a true statement. Let's look at the next one, the inverse. So we want to do not P, not Q. If today is not a weekend day, if today is not a weekend day, then tomorrow is not Monday. So if today's not a weekend day, that means it's going to be like Monday through Friday. The next day is not going to be a Monday. So this is also a true statement. And the third one, the contrapositive. We have not Q implies not P. So if tomorrow is not Monday, Change colors on. If tomorrow is not Monday, oh wait, no. Oh yeah, we'll change it. If tomorrow is not Monday, then today is not a weekend day. So let's see, if tomorrow is not Monday, let's think of a case where this would be true. So tomorrow's not a Monday. So let's say tomorrow's a Friday. Yeah, let's say tomorrow's a Friday. So today would be a Thursday. Um, let's say tomorrow is a Sunday. It's not a Monday. That fits that part. That makes that part true. Then today is not a weekend day, but today would be a Saturday. So if today is actually Sunday, we would say, no, if today is Saturday, then tomorrow is not Monday. That fits because tomorrow would be Sunday. But today is a weekend day. That causes this to be a false statement. Because I can think of a counterexample. Today could be Saturday, which would fit the first part, but cause the second part not to work. Let's see. Let's look at example 5 here. Write and evaluate a biconditional. Biconditional is P double arrow Q, P if and only if Q, or Q if and only if P. So the order doesn't matter in a biconditional. If we can write a biconditional, it's assumed to be a true statement, or it needs to be a true statement. So here's our conditional. And then we need to check its truth value. If two lines intersect at right angles, then they are perpendicular. So here's our hypothesis, single underline. Here's our conclusion, double underline. And we want to write the biconditional, so we want to write it as two lines intersect at right angles if and only if they are perpendicular. So two lines intersect at right angles if and only if, and IFF means if and only if, they are perpendicular. This is pretty much our definition of perpendicular lines. So let's see if we can evaluate this. So two lines intersect at right angles. So we got two lines crossing each other, making a right angle. By definition, if they make a right angle, they're perpendicular. So this is a true statement. We also could have written, if two lines are perpendicular, then they intersect at right angles. No, two lines are perpendicular if and only if they intersect at right angles, would be the other way we could do the biconditional. Let's look at number 6. What are two conditionals associated with a biconditional? The product of two numbers is negative if and only if the numbers have opposite signs. So one of our parts is the product of two numbers is negative, and the other part is the numbers have opposite signs. So one of these could be the conclusion, one of these could be the hypothesis, or vice versa. So let's see. So we want to write the two conditionals associated with it. So if the product of two numbers is negative, then they have opposite signs. So that's one form. That's taking, this is the P, and this is the Q. We also could, again, the biconditional is P double arrow Q or Q double arrow P, P if and only if Q, Q if and only if P. We took care of the P if and only if Q part. Now we got to do the Q if and only if P. So if the product of two numbers have opposite signs, comma, then their product is negative. So here we have the Q P conditional. Here we have the P implies Q conditional. And I think that's it for the TryIts and the student companion.